Hello everyone, and welcome to the second half of our ratios and rates course. Now, in the last 4 or 5 videos, however many it was, we talked about the idea of ratios. And we thought of ratios as comparing quantities, so comparing some number to another. And a lot of the time, we were dealing, well, pretty much all the time, we were dealing with the same units. So when we talked about, for example, the ratio when we have of 3 to 1 for our cordial, the things here were measured in the same units because we had just three glasses of one thing for one glass of another thing. So these are measured in the same units, but rates are another way to compare two things, but however, rates compare quantities measured in different units. So ratios deals with the same units, rates deal with different units. So let's quickly define rates. As I said before, these compare quantities, so amounts of certain things, quantities measured in different units. Cool. That is the short way to define this idea. Now, whether you've heard of this word rates yet or not, you've actually probably come across it more than you may have realized. And we're going to look at a bunch of these examples throughout the tail end of this rates course. But one very common one is in a car. So say you're driving with your family, you're going on a road trip, and you say you're sitting in the driver's seat. Some of you may already be driving, who knows? But you would see what we call a speedometer. So you would have this thing on your car dashboard, and it has these different speeds. It's got 20, 40, 60, 80, 100, 120, let's say 140, it ends up. And this thing measures your speed. So say I'm driving on the highway and my speedometer, my needle is over here. Now, some of you, the ones that come from, for example, Australia, where we use the metric system, we measure speed in kilometers per hour. Now, this thing is a type of rate. So if my little speedometer dial is here on the right, this tells me, in other words, I am traveling, or I will travel 100 kilometers for each hour. So say I maintain a constant speed on the highway, I flick my car in cruise control, and I'm driving at 100. Now this tells me I'm traveling 100 kilometers each hour. So if I drove along my along this highway, every hour I'm going to cover 100 meters. Now, this, whether you may realize or not, is a type of rate because it is comparing two different measurement quantities. It's comparing distance and time. These are two measurement quantities which are different units. And we would write this, for example, it's convention in maths. We write this with a slash. So say I wanted to show this, I'm writing this as 100 kilometers per hour. This slash thing here means per. So it's another way of saying 100 kilometers per hour or 100 kilometers every hour. Now, this notation that I've written up here, this is telling us, in essence, 100 kilometers per hour or 100 kilometers each hour. That is another way of saying this. This is what the information is communicating to us. And that's what it tells us on my little dial on my speedometer when I'm driving along the highway. And we express rates in a bunch of different ways, but we're always looking at two measurement units. And in maths, it is conventional to write rates in their simplest form. So for rates in the simplest form, this means writing the rate for only one unit of the second quantity. Now, we'll talk about this in a second. So this means writing rate for only one unit of second quantity. So if you look up here, for example, this we expressed as 100 kilometers for each hour or for 1 hour. So we're driving 100 kilometers, and this thing here was expressed as to 1 unit, so 1 hour, 1 measurement quantity. Now, let's look at this and let's think about how we could convert these rates using different bits of information. So let's say, for example, someone is working at a job and they earn $45 for 3 hours of work. Now, this particular thing here is a non-simplified rate. This means it's not written for only one unit of the second quantity. It's not written in its simplest form. So this thing here, I'll write NSR. That's the non-simplified rate. Now, if we wanted to convert this to an easier way to write this, so if we wanted to find out how much this person was making per hour or for 1 hour, we can use something that will hopefully be familiar to you. We talked about this quite a bit recently, but we're going to use what we call the unitary method. So if someone makes $45 for 3 hours, to find how much they made in 1 hour, we're going to just divide both of these by 3, because that's going to tell us how much I get in 1 hour or per hour. So this I can write here as, when I divide 45 by 3, I get 15. And when I divide 3 hours by 3, I get 1 hour. Now this thing here is what we call a simplified rate. And that now we can write in the convention we have gotten used to before in the previous example. So we write $15 per hour. So that's what we mean by only one unit of the second quantity. So this one here, my 3 hours, or my hours in general, that's my second quantity. And I'm doing something mathematically to that. Here I'm dividing by 3 to give us 1 unit of that quantity, of that measurement. That's what we mean by this. Now let's look at a couple more examples. Now, let's try here. Question 1. So we want to write a simplified rate for $28 for 4 kilograms. Kgs. So let's say I've gone to the butcher and I want to buy some meat, and I say to the person, well, I want 4 kilograms, please. And he says, sure thing, that'll be $28. I want to figure out, well, how much did I pay per kilogram of meat? And this you'll often see in the shops as well. If you go to the butcher or something, all of their meat, for example, is priced at some amount of money per a unit of measurement, per gram, per kilogram, etc. So this has a lot of real life applications, especially when we think of rates. So I want to find what I'm getting for how much I'm paying for 1 kilogram, because I'm going back to this definition again. Rates in their simplest form are written for only 1 unit of the second quantity. This is my second quantity. I want to write how much I'm paying for 1 kilogram instead of 4. How can I do this? Well, we can think, how can I get from 4 to 1? Well, I can divide by 4. We're using the unitary method here again, guys. So I'm dividing both of these by 4 to find out what I'm paying for 1 kilogram. And I'm going to end up with $7 for 1 kilogram. This is in my simplest form now, which I can write as $7 per kilogram. My second unit is in its simplest form. It's expressed to 1 of that unit, of that measurement. Okay, cool. Let's try one more example. I want, and this is, we're talking about finding an average rate. And a good example for something like this is something like growth, right? So my audience, I'm guessing a lot of you will probably be teenagers. So you would have had a growth spurt over a certain period of time. So, when you're at the end of primary school or starting high school, your height just shot up. Now, your height doesn't always increase at like a really constant rate. You're not going to, when you grow, you may not go in a very constant, all right, my growth's going up and up and up and up, right? In the same as maybe driving constantly for 100 kilometers per hour, like we had in the driving example. We're not staying on this. Sometimes your height can actually shoot up. So you may grow, for example, in 1 year really quickly compared to another year. So this is where we want to find an average rate. Now, how can we find that? Well, let's look at a question. So this says that Tom was 120 centimeters tall at 10 years old, and he was 185 centimeters tall at age 20. Now we want to find his average rate of growth per year between 10 and 20. So we want to find average growth per year between the ages of 10 to 20. Okay, I'm just trying to write this quickly so we don't waste too much time. But now, what's important to note here is this isn't saying, whatever answer I get, isn't saying that, okay, he grew a certain amount every year, this exact amount. No, his height would have shot up maybe 1 year. Maybe when he was 14, his height shot up and then it slowed down later. Rates can change constantly, right? But all we're finding now is we're comparing two ages. We're comparing his age at 10 years old and his age at 20. And then we're figuring out, well, how much did he grow roughly on average? We're trying to find, if you remember back to statistics, roughly the midpoint. So kind of how much he's roughly grew every year as an average over these years we're measuring. So first we have to find, well, how much did he grow and over how many years did he grow? So we want to first find his growth. And we're expressing his growth in centimeters. Sorry, I just realized this 2 looks really ugly. Okay, we want to write his growth as in centimeters. So growing from 120 to 185, we can find how much he grew by taking the difference between these. By going 185 centimeters minus 120 centimeters. And by doing this, we find that he grew a total length of 65 centimeters. And then the next part of our question, remember we're finding the average growth per year. So the years is that second quantity we're measuring my growth against. So that, to find the average, we need to find, well, over how many years did he grow? Now, the years he spent growing was from the age of 10 to the age of 20. How many years had passed from 10 to 20? Well, we can find this by taking the difference, by going 20 minus 10, and that gives us 10 years. Now, let's just write down how much Tom has grown. So he has grown 65 centimeters in 10 years. Now, we want to find this as a rate and as a simplified average rate. So we want to find how much he's grown to one of the second unit. So 65 centimeters in 10 years, we want to find how much he grew per year in 1 year. And to do that is no different to how we've been approaching these questions up until now. We want to find how much did he grow in 1 year? And we can get that by taking this 10. How can we get from 10 to 1? We can use the unitary method. We can divide 10 by itself to get us to 1 unit. And I'm dividing my 65 centimeters by 10. And I get now that he has grown 6.5 centimeters in 1 year. Or, now that I have this in the simplified form, he has grown on average 6.5 centimeters per year. Now, I've said this before, but I'll say it again. We are looking at his growth, his average growth per year. This doesn't mean that, okay, each year I've measured Tom from 10 to 20, it's gone up 6.5, 6.5, 6.5, 6.5 each year. So 10, 11, 12, 13, 14. This height and the rate of how much his height increased probably fluctuated. It went up and down. Maybe one year his height shot up. Maybe another year it stayed the same or only went up slightly. Rates change. And we're going to be looking at this a lot more in this course. And this idea goes all the way through high school, the high school maths syllabus. But all we need to know now is that we can find an average rate. That's what we've done here. And all rates compare two different quantities. Some quantity per one of another quantity. Here we looked at centimeters per year. In the other questions, we looked at some other types of these other types of rates. But that's all I want to take away here. And we're going to go through a lot more of these ideas that I've previously mentioned in the following videos. But let me just give you one more question just to practice at home. So this is a practice question. So I want you to write a simplified rate for if we have 36 students for 3 teachers. I want you to find how many then students we have for 1 teacher. So I want you to find this as a rate of some amount of students per 1 teacher. Have a go at that one, guys. Thank you so much for watching, and I'll see you in the next video.